Okay, so we are on page 14. So as promised yesterday, we are going to rotate the axis. So yesterday we basically moved axis and we basically moved it around left and right, up and down, still kind of in a rectangular fashion. Today we are going to rotate. So let's go ahead and draw the new axis. So this old axis is in XY. What we're going to do is we're going to rotate this. So we're going to have a new axis. Let's call this X prime and Y prime. And then this angle of rotation, let's call this alpha. Okay, and then let's say that we have this point somewhere here. And we are going to call this point P. And in the old system, it has XY, or it is XY. All right. I am going to try not to confuse you. Yes?
Is it a 1, like an exponent, or is it like a sideways?
It's a prime. Like in geometry, when you move things, you always put a prime. So that's the same thing, prime. Prime is just like that.
An apostrophe.
Yes, correct.
Thank you.
Okay, how should I explain this so it's a little better? Let me think. Okay, actually, let's do this in X prime, Y prime. So basically, what we're doing is X prime, Y prime means that you're going to get to this point by going X prime, Y prime, like that. Okay, so you're going on the rotated axis. Okay, so we are going to try to relate the X prime, Y prime axis to the X and Y axis. So we're going to see how they're connected so that we can write some formula. So then when we have a point, we know what is this point in the XY coordinate? What is this point in the X prime, Y prime coordinate? Okay, so let's draw some lines. Okay, straight down. That is 90 degrees, right? So then we know that this length is X prime. This length is Y prime. Makes sense, right? If you're going to rotate your head and then you go to that point, you go X prime, Y prime, and that gets you to the point.
So just for clarification, X prime is the whole line, not just a certain amount of it, right? It's not like a vector, it's the whole line is X prime?
Okay, there are two meanings to X prime. X prime is the axis, but in my case, that's the length. Yeah. All right. So the task today is figuring out how do I get to the same location if I go X and Y only. Does that make sense? I know how to get to this point P by going X prime, Y prime. What we're going to do today is figuring out how to get to the same point if I just go X and Y. So what is X and Y in relation to X prime, Y prime? Does that make sense? So this is the question of the day. All right, so somehow we need to relate the green to the red. This is a little difficult. Okay, so we need to figure out how long is this green part. How long is this green part? Or that one is a little bit too long. Huh? Yeah, how long is this green part?
If you use the direction angle as your angle, couldn't you just make it like, if you found the length of X prime, couldn't you use sine and cosine?
Yes, perfect. All right, so we've been talking about that for 2 chapters already, right? Okay, so basically we have this triangle. And then if we have this length here, this part, which is X, is, let's say this is theta. This is R cosine theta, right? And then the other part is R sine theta. And we've been doing that for a long time now. We're going to use the same thing to relate these lines together. Anyways, okay, so this part is x prime, which is this length, if you think it's basically a hypotenuse to here. So if I draw a straight line down and then create a right angle here, then x prime cosine alpha is going to be this length, right? Yes? But that's too long, right? Because if I want to figure out what the green is, I need to subtract out this part. So I got to figure out what that part is. But at least we have something. Okay, so let's write that down. This part, it's going to get quite messy. X prime cosine alpha.
Oh,
And then we have to figure out what this part is so we can subtract it out.
Are we going
Yeah.
to use both of the triangles? So I see two triangles.
Yeah, we're going to use all of the triangles, so it's going to get a little
So
crazy.
The two green lines and then the red line, like half of it, and then a little triangle up this.
You mean here?
Yeah, that little
Yes,
triangle.
we're going to have to use this triangle to help us figure out this part.
Okay.
Thoughts? How do we figure out this length?
Could you project y prime onto x prime to get the length of the bottom part?
Y prime onto x prime. Y prime onto x prime. Well, y prime and x prime are 90 degrees. They're not going to project.
Oh, I see. Okay, so it'd have to be.
So we need to figure out how long is this part.
Find that little triangle up there and then use like the reverse of the area. So you need the height. Something like that.
Yeah, if we draw a line from our y-axis to the point on the right, then you can find y prime is hypotenuse of that.
Yes, it has something to do that with that. Let me make sure I am looking at the right thing on mine. Okay, this is going to be really hard to see. Yes, it has to do with that part.
Okay.
This part, which is this triangle. Were you guys thinking about that too?
Yeah.
So, I can't really rotate it, but you can kind of rotate with your head. This length here is what we want to subtract out, which is this hypotenuse, like sine of this angle, right? That's going to give you this.
Why
Yeah.
don't we use similar triangles?
Yes, that's also a very good question. Yes, you can use similar triangle. Which triangle are you looking at?
There's two like an 8 triangle, like a the big one and the small one.
This,
The two other triangles.
The one that's both connected to the Y.
this one and this one?
Yeah.
Yes.
Are they mirror images
No,
though?
They're
Uh,
similar.
yeah, they're similar. So this angle is alpha.
Yeah.
This angle is alpha.
Then one on the opposite side would be alpha.
So that would be 90 minus alpha.
Yeah. And then the one underneath it is alpha.
Is that what you're thinking, or no?
No.
No. Okay. How would you find that blue line?
Because you already know y prime.
Mm-hmm.
So, and the long.
You said numbers.
No,
Oh.
it's just a thought.
Oh wait, couldn't?
I know what you're saying, but it is not. I think if you wanted to use similar triangles, this line would have to be flat.
Yeah.
Because your triangle's going like this, which they are similar, but we are trying to figure out this length,
This
which I don't know if this one. I don't think it's this one. So.
Because we found alpha up there, and because y prime and x prime are orthogonal, can't we just say that it's the same thing as if you're reflecting the other side? So like right here, this is whoops. Like this angle is that, so we can.
That angle is that. Yeah. That you're right.
We don't have any set numbers to work with, so we
Yes,
have
this is alpha as well.
to. Yeah. So then from there, can't we?
So then
Find
this
the-
this blue one is going to be
Cosine.
y prime sine alpha.
Yeah.
Yeah.
Then we can use that at the bottom and subtract the n y prime. Sine.
Are everybody else following? No.
I can't see yellow. Can you do it in a different color?
Yeah, the app I'm using right now is very limited in colors. I only have that one I can't record. So
Black.
okay,
You can't see
alpha 90 minus alpha.
There we
This
go.
is. Thank you for your approval, Taya. Okay, so y prime alpha, which is this part down here. This is y prime sine alpha. So finally, we have one of the relationship.
Oh.
Huh? Can see it?
I can trade
Okay,
my-
so x prime. What is it? Sorry. X is the same as saying x prime cosine alpha minus y prime sine alpha. Okay? Hey,
Where'd you go?
this is the length minus this y prime sine alpha, which we found out here.
Everything's
So
gonna be so long.
you can write something else, but when you talk to us, please say alpha. Okay, so that's x. We can do the same thing for y, but I really don't want to go through another one of this. I'm just going to tell you how it is. But basically, this is kind of the thing that, if you don't convince yourself and you're just memorizing a formula, it's going to get very, very hard of trying to follow along. Yeah.
Is it alpha 45 degrees? Like
In this one, it looks like 45 degrees, but it can be anything.
No, because it's 90, and then you have two other angles, but that one.
No, we don't want to assume it's 45. It could be anything. All right, so let's just write the answer for y. So that's going to be x prime sine alpha plus y prime cosine alpha. And then to go in the other direction, x prime is x cosine alpha plus y sine alpha, and then y prime is negative x sine alpha plus y sine alpha. Now this alpha, which is the angle of rotation, is between 0 to pi over 2, meaning between 0 and 90 degrees. Okay, between 0 and 90 degrees, because if you turn it more than 90 degrees, it's going to basically be something else. Anyways, so between 0 and 90. All right, now how do we actually use this? Well, rotation has to do with the xy term, which in your general conics equation, when xy exists, your conic shape, if you try to graph it, it's going to tilt. It's going to be a tilted ellipse, a tilted hyperbola, tilted parabola, something like that. So we want to figure out, for example, this one. Prove that 2xy minus 9 is really just a hyperbola where you rotate it by 45 degrees. All right. So they're saying that this would be the same as a hyperbola if I had rotated by 45 degrees. So how do we do this proof? Okay, so what we want to do is change everything in terms of x prime and y prime, and then try to solve the equation so that shows me a standard hyperbola equation, but in x prime, y prime. Basically, the xy term has to be gone. Okay, so let's try this. X is equal to x prime cosine alpha minus y prime sine alpha. And then all these equations I'm going to give you on the test, so you don't have to memorize these. It's
Thank you. Yeah.
kind of a one-off thing, don't spend a lot of time memorizing. Okay, so what we're going to do is we're going to change x and y so that they're both in x prime, y prime. And to do that, I take the definition of x, and then with the x prime, y prime, and put it in here. The definition of y with x prime, y prime, and put it in here. And I'm going to change this whole equation so it's just x prime, y prime. And I'm going to try to see if it's going to look like a hyperbola. Okay, anyways, just follow along and then that will make more sense. All right, so this is x prime cosine pi over 4 minus y prime sine pi over 4. All right, we're just substituting. Okay, so solving now. Cosine pi over 4 is square root 2 over 2, and then x prime minus square root 2 over 2 y prime. Okay, so that is x. Okay, we're going to do the same thing with y. Y is equal to x prime sine alpha plus y prime cosine alpha. Okay, doing the same thing. X prime sine pi over 4 plus y prime cosine pi over 4. So square root 2 over 2 x prime plus square root 2 over 2 y prime. All right, now we are going to substitute it into the equation. 2xy minus 9 equals 0. 2, let's make it a little bit simpler. I'm going to take out the square root 2 over 2, so it's not so busy.
With the FOIL.
Yes, but taking out the square root 2 over 2 is going to make it a little easier.
Oh, what's y stuff squared?
Okay, so just follow along. I'll solve this one for you. Okay, so 2xy minus 9 equals 0. I'm going to substitute in x and y. So this is going to be 2 times x. X is square root 2 over 2 and times x prime minus y prime. Y is square root 2 over 2 x prime plus y prime. Minus 9 equals 0. Again, so what I'm doing is I'm changing xy into x prime y prime, and then I'm going to look at the equation and say, is this a hyperbola equation? Because if you just look at 2xy minus 9, it does not look like a hyperbola. But they are telling us it is a hyperbola if you rotate it 45 degrees. Okay, so let's solve this. Bring all the constants to the front. So that's going to be, what is this, 1? Yeah, square root 2 times square root 2 is 2. 2 times 2 is 4. 4 over 4 is 1. So that's going to be just 1. And then x prime minus y prime times x prime plus y prime is x prime squared minus y prime squared minus 9 equals 0.
That's not listening to that.
Wait.
Oh, never mind, never mind.
How'd you get
How'd you get 1?
Okay. 2 times square root 2 times square root 2 is 4. Yeah? 2 times 2 is 4. So 4 over 4 is 1. All right, so put that 9 over on the other side. X prime squared minus y prime squared equals 9. Does this look like a hyperbola equation?
Now it does.
Yes,
Yes.
it does. So it is actually a hyperbola, but rotated 45 degrees. Now go ahead and graph it and see if it's actually a hyperbola.
We just grab it with x.
Oh, well, the only thing you can graph is this one, right? You want to check to see if this is a hyperbola that's rotated 45 degrees. How do you do it in your calculator? You have to change it into xy. So 2xy minus 9 equals 0. So 2xy equals 9. So y is equal to 9 over 2x. So if you graph that in the calculator, it should show you a hyperbola, but rotated 45 degrees. Or you're like, I never thought of it as a hyperbola, but it is.
Isn't that one of those functions?
Wait, so is it just like
Yeah.
Is this invalid?
it's just a line?
No, it's not a line. 9 over 2x.
Yeah.
Yeah.
9 over 2x?
What?
No, it's
No,
not
it
a
looks
line.
like that.
Zoom out.
It's
Looks
like
that,
this.
what she points to.
You gotta put
Oh, wait,
the 2x
you're probably putting it in wrong.
Oh, okay. You have to put the 2x in parentheses.
Yeah,
Or it's gonna be 9 over 2 times x.
So it's basically like this, right? The rational functions. So you just never thought of rational functions as a hyperbola turned 45 degrees.
Oh man.
Just blew your mind. So this is really just the hyperbola but turned 45 degrees,
That's pretty cool.
right? you basically saw a function like this. It's just hyperbola turned 45 degrees. You don't see it?
It's like this.
Yeah. Oh, right, because you put in the original equation. So like if you rotated 45 degrees, you would see a hyperbola. Alrighty. Let us try another one. Okay, so not this one. Let's try xy equals 8. Angle of rotation is also pi over 4. So you have to show that this is a hyperbola. All right. The answer is x prime squared minus y prime squared equals 16. Okay, or in some form, similar to that.
We're supposed to find
Why is it 16?
Squared.
Oh, no, I changed the question.
Times 2.
Oh.
Right, xy equals 8. Were you guys using that?
Yeah. Start off. Dang it.
Look at the board.
Wait, did you do it?
Yeah. So x is equal to
Or you can skip all that, like,
Huh?
like it's pi over 4.
okay.
Do the other part.
Okay, so xy is going to be square root 2 over 2 x prime minus y prime times square root 2 over 2 x prime plus y prime is equal to, what's it, 8. So this is going to be square root 2 times square root 2 is 2 over 4, so 1/2. 1/2 times x prime squared minus y prime squared is equal to 8, so that multiply both sides is going to be 16. All right, we're now going to go backwards. I'm going to give you an equation. You're going to figure out what is the angle of rotation. So there's a formula for angle of rotation. Angle of rotation formula is cotangent alpha is equal to a minus c over b. And these a, b, c has to do with the general conics equation. Okay? And then, right, I'm sorry, this is cotangent 2 alpha, not alpha, 2 alpha. Okay, so remember that alpha is between 0 to pi over 2, so therefore 2 alpha is between 0 to pi. So between 0 and 180 degrees. Okay, ABC has to do with that whole equation I had you guys look at, was it 2 days ago? Yesterday? So, for example, let's look at this question. What is the angle of rotation for this whole big equation? Well, the angle of rotation equation is cotangent 2 alpha. John, are you with us? Okay, is equal to a minus c over b. Now let's talk about ABC. What value is a?
X squared.
Oh, no. A has to be the number. ABC, they're all numbers. What's a?
1. Oh, 4.
1. Okay, so it goes A, B, C, D, E, F. Okay, so if you don't remember that, go back to the beginning of the section. It has it all laid out for you. You have to make sure you know what letter goes with which term. Yes.
I don't answer no question.
Willie. Okay, what number is B?
4.
Okay, what number is C?
4.
Okay, so this is going to be 1 minus 4 over 4. Right? Yes. So that is negative 3 over 4, which is cotangent 2 alpha. Okay, you're going to go back and figure out what alpha is.
Okay.
All right, you're going to have to... Do you need me to help you or you're okay?
Do the double for me.
You don't have to. You're just going to use your calculator. But it's a cotangent, so you're going to have to... Okay. Let us do... let's draw a triangle. Okay, cotangent is what side over what side?
Cosine over sine.
What side over what side? Opposite, hypotenuse, and which one?
Adjacent over opposite.
Adjacent over opposite. Okay, good. Adjacent over opposite is negative 3 over 4. Let's see. It has to be somewhere here. Okay, adjacent over, so... Yes.
But it's 2 alpha, it's still negative 0.4.
Yeah.
Yes, we eventually we have to divide by 2 to find alpha.
Oh.
Okay, so now remember I said in here, alpha is between 0 to 180. Therefore, we are not considering any of these bottom parts. Okay? Because alpha is only between 0 to 180. So negative 3/4 is here, where the adjacent side is negative 3, the opposite side is 4. So we are going to figure out this part, which is 2 alpha. You guys can do this, right? We
Yeah.
did this last
A
chapter a lot. Yeah, we did do this a lot. Okay, so go ahead and figure out what alpha is. Okay, so 2 alpha, I don't remember what the number is. 126.86, something like that. So then remember to divide by 2, so it's going to be 63.43. So the angle of rotation is 63.43. Now if you graph it in the calculator, which is a little bit hard, you're going to have to solve for y, right? We learned that yesterday, solving for y. And then you graph it, you're going to see that it's going to tilt a little bit, and it's going to tilt exactly 63.43 degrees. All right. Okay, there is a very hard part that we're just going to skip. We're supposed to solve this whole equation into just x prime, y prime. It gets really crazy. It'll probably take you 30 minutes for one problem. So I'm going to skip all that. And then the last thing I'm going to tell you is how to figure out what shape it is by ABC. All right. How can you tell what kind of shape that should be? It has to do with b squared minus 4ac. Which is the discriminant part of your quadratic formula. So it's a hyperbola if b squared minus 4ac is greater than 0. B squared minus 4ac is 0 if it's going to be a parabola, and the ellipse b squared minus 4ac is less than 0. Okay, so to tell what kind of shape it is, you do b squared minus 4ac. So let's have you practice. 2xy minus 9. You're going to figure out what shape that's going to be. 2xy minus 9. Okay, 2xy minus 9. A, B, C. What number is A?
2. No?
0.
Oh.
What number is B?
2.
Okay, what number is C?
0.
0. Okay, b squared minus 4ac. So that is 2 squared minus 4 times 0, which is 2. What shape is that? Hyperbola. Okay, so it tells you that if it's greater than 0, it's a hyperbola. So this is a hyperbola. You can always graph it and look at it. Sorry. 4. Yeah, sorry. Oh, cannot erase it again. I'm sorry. 4. Yeah, okay, go ahead and try this next one. All right. Number 2, parabola. A, B, C.